So for this part of the notes, we're going to put it all together. So just to recap the tools that we had initially that information about KW, and I had that triangle, if you like to think of that. Basically, the KW, and we know that that's 1.00 times 10 to the negative 14, is the product of the hydrogen ion concentration and the hydroxide ion concentration. And so if you have one, you can find the other. So that's how Kw up here on the top of this square is the thing that goes between those two concentrations. If we're going to, oops, I forgot Kw at the top. If we're going to go between our hydrogen ion concentration and pH, that was the logarithm equations. And so we had the pH was the negative log of the hydrogen ion concentration. The opposite of that, if we went the other way, it was written in math like 10 to the negative pH, or I did it in the notes with our calculator as the inverse log, which is not mathematically correct, of the negative pH. And so that would be the way that I would remember it, in a practical way for going between the pH and the hydrogen ion concentration. Basically duplicating that logic, we went between the hydrogen ion or hydroxide ion concentration and the POH. And so for that, we have the equation right there. And going the other way from pH back up to OH minus, we would have, your version or the mathematical equation of that. So if you want to fill it in because you're not sure how to use your calculator, you haven't studied logs before, inverse log or second function log, or however your calculator was making it work. Oops, and that's a typo. That should be POH in there. So the other thing that we had is when we were talking about hydrogen or concentration and then our pH and POH, we had that idea that it was sig figs in concentration, and that would be in moles per liter for concentration. And then that indicated how many decimal places in our pH or POH. And so as an example, if you have 2.0 molar, that would be 2 decimal places. So 2 sig figs be 2 decimal places. And so that's what we were talking about with that. I won't do that example because I can't do it that quick in my head. Should have picked one that was not a number. Okay, so the last thing that we had is kind of where we left off the last video, in that pH and POH, if you wanted to go between these two, they add up to 14. And this one specifies that it's actually 14.000. It's exactly 14. And so those zeros are on here just to satisfy any sig fig questions. We don't want to limit it with that concept. And so it's really exactly the 14.0. So this acid-base square is really the topic that we're going to use to answer the questions on the next 3 pages or 2 pages. So basically, it allows you to move around between these different concepts, right? So we have our concentrations and our pH and POH, and basically you can move around the square any which way you want. You have options. So if you know the pH, you could figure out the hydrogen ion concentration, right? If you didn't want it to do it in a multiple number of steps, you could go all the way around here. One word of warning here is that you cannot go across like that. That is impossible. You're not allowed to do that. That's not how this thing works. And so you have to go around the square, and having a bit of a picture can be helpful in this. So the bottom example here, I'm going to do one with you or for you. And so basically in these questions, you're always going to have some piece of information that you start with. So this is the given piece of information. So I need to fill out this chart to kind of complete all the others. And you can do it in whatever order you like. So in this one, if I want to figure out pH, the equation for that is it's the negative log of my hydrogen ion concentration. So we have here that filled in, and if I were to do the math on that, that is equal to 7.5086. So in these, we want to keep track of those unrounded numbers. You can store them in your calculator, or I have a bit of a sweet spot. If I keep about 4 or 5 decimal places, it seems to make things work out just fine for me. Giving this as an answer, I have 2 sig figs in my concentration, so I'd have 2 decimal places in my pH. And I use this convention where it's equal to, this is unrounded, and then when I put the arrow, that means that I've rounded that number for sig figs. Because if I use this number now, I don't want to perpetuate any of those rounding errors. So if I were to move across on this, I could go from the given information to the next thing in the chart. So if I want to go between the 2 different ion concentrations, I would use that KW relationship. So the thing that I'm looking for, in this case the hydroxide ion concentration, is equal to KW divided by the thing I know, which is the hydrogen ion concentration. So these are the numbers filled in here. Again, if I were to calculate this on my calculator, oops, 5.8, I put a few extras in there, -7 moles per liter, and I would give this to 2 sig figs, so 3.2 times 10 to the -7 moles per liter. Don't forget the units where you need units. People can get sloppy at forgetting those capital M's, or moles per liter, or molarity. So the last part here, if we want to get to POH, we actually have options, right? You can do it one way or the other. In all honesty, I have a much easier time subtracting a value from 14 than doing a log calculation on my calculator. So if I were to do what I think is the easier, it's exactly 14 minus my unrounded number. It won't really make a difference, but that's a good strategy to have. I get the POH would be 6.49. Just to highlight that it is possible to go from other corners on the scale, if we wanted to, we could go direct from our hydroxide ion concentration to our POH. And so the equation for that would be that it's equal to the negative log of that hydroxide ion concentration. So subbing that in, I'd have negative log of my unrounded number from over here, 3.2258 times 10 to the -7, and using my calculator on that, and then rounding. I didn't write the exact number because I'm actually done with this question. I get the exact same value for the POH. So it doesn't really matter. It's a bit of a choose your own adventure. You can do what you think is easiest. Couple words of warning is that using your exact value that you're given as many times as you can is a safe bet. And also this convention of writing down your unrounded numbers, so you use those as opposed to perpetuating rounding errors. So the last thing on the chart here asks, is this solution acidic, basic, or neutral? And it has a pH of more than 7, so that would make it a basic solution. So what we're going to do is use this theory, and there's 4 more examples for us to do. I'm going to go to my key that has all of my work shown, and I tried to really do my answer key here so that it would illustrate everything that you would need. So I try to put the equation at the top and sub in. I stay with that convention of writing down my unrounded number and then giving my answer with that arrow and putting it in the box. You may need to pause the video as you work through, but these are the first 2 examples, and then I'm going to switch it to the last 2 examples. So that does us for this chapter, or sorry, this section of the chapter. We've got one more bit to do when we talk about acids and bases and stoichiometry.